Welcome to Operating Systems Interview Crashcasts, your go-to podcast for acing those tricky-OS questions in TESH interviews. I'm your host, Sheila, and today we're joined by Victor, a seasoned backend engineer. We'll be diving into a common yet crucial question about operating systems. Victor, are you ready to get started?
Absolutely, Sheila. I'm excited to share my knowledge and hopefully help our listeners prepare for their interviews.
Fantastic. Let's jump right in. Victor, here's our question for today. What is an operating system and what are its main functions?
Great question, Sheila. At its core, an operating system, or OS, is a software that manages computer hardware and provides services for computer programs. It acts as an intermediary between the computer hardware and the user, making it easier for users to interact with the computer and for programs to utilize hardware resources.
That's a solid start, Victor. Could you elaborate on some of the main functions you mentioned?
Certainly. One of the primary functions of an OS is process management. This involves scheduling and coordinating the execution of multiple programs or processes. The OS ensures that each process gets its fair share of CPU time and manages the switching between processes, known as context switching, which is essentially the OS saving the state of one process and loading another.
Interesting. How does the OS handle multiple processes running simultaneously?
Well, modern operating systems use techniques like multitasking and time sharing. Multitasking allows multiple processes to run concurrently by rapidly switching between them, giving the illusion of simultaneous execution. Time sharing allocates CPU time to each process in small intervals, ensuring fair distribution of resources.
That's fascinating. What about memory management? How does the OS handle that?
Memory management is another crucial function. The OS is responsible for allocating and deallocating memory to various processes. It keeps track of which parts of memory are in use and which are free. Additionally, it implements virtual memory, which allows processes to use more memory than physically available by utilizing disk space as an extension of RAM.
Could you explain virtual memory a bit more? It sounds quite complex.
Certainly. Virtual memory creates an illusion of more memory than physically exists. It divides memory into fixed-size units called pages. When a program needs memory, the OS maps these virtual pages to either physical memory or disk storage. If a program tries to access a page that's not in physical memory, the OS loads it from disk into RAM. This process, called paging, allows for efficient use of available memory resources.
That's a great explanation, Victor. Moving on, what other key functions does an operating system perform?
Another important function is file system management. The OS provides a logical view of data storage, organizing files into directories, and providing operations like creating, reading, writing, and deleting files. It also manages access permissions and ensures data integrity.
What about device management? How does the OS handle various hardware components?
Device management is indeed crucial. The OS manages communication between software and hardware devices through device drivers. It handles I/O operations, allocates devices to processes, and provides a uniform interface for different hardware components. This abstraction allows software developers to write programs without needing to know the specifics of each hardware device.
That's very interesting. Now, let's consider an edge case. How do operating systems function in embedded systems, which might have limited resources?
Excellent question, Sheila. Embedded systems, like those found in IoT devices or automotive control units, often use specialized operating systems. These are typically real-time operating systems, RTOS, that prioritize deterministic behavior and low latency. They're designed to be more lightweight, with a smaller memory footprint and fewer features compared to general-purpose OS. RTOS focus on task scheduling and inter-process communication, often sacrificing features like virtual memory or complex file systems to ensure predictable, time-critical performance.
Thank you, Victor, for that comprehensive answer. As we wrap up, could you summarize the key functions we've discussed?
Certainly. The main functions of an operating system include process management, memory management, file system management, device management, providing a user interface, and ensuring security and protection. Each of these functions works together to create an efficient, user-friendly, and secure computing environment.
Excellent summary, Victor. Now, for our listeners preparing for interviews, here are some tips. First, make sure you understand the basics of each function we discussed. Be prepared to go into depth on at least one or two areas, like virtual memory or process scheduling. Also, consider real-world examples or specific OS implementations to demonstrate your practical knowledge. Lastly, don't forget to mention security and user interface aspects, as these are increasingly important in modern systems. A common pitfall is focusing too much on textbook definitions without considering practical applications. Try to relate your answers to real-world scenarios or challenges you've faced in your work. Remember, interviewers are often looking for how you apply your knowledge, not just whether you can recite facts. That wraps up our episode on operating systems. Thank you, Victor, for sharing your expertise, and thank you, listeners, for tuning in. Until next time, keep coding and good luck with your interviews.